Look at Math Workshop. Your Math Workshop test will probably be next Friday, okay? Math Workshop test is next Friday. Arc sine, and somebody over every one of these pieces of paper, arc sine. Where does arc sine live at, guys? In quadrants what? 1 and 4. Sine deals with what? The x or y value? Y. Which reference angle has a y value of square root of 3 over 2? Pi over what? 3. Very good. Which pi over 3 family member lives in quad 1? Pi over 3, because it'd be quad 1 because that y value is positive. Arc cosine 0. Where does arc cosine live? Quad 1 or 2. And remember, cosine deals with what value? X. Which reference angle or which angle has an x value of 0? Very good. Pi over 2. Arc cosine of square root of 2 over 2. Okay, which reference angle does that deal with? Pi over 4. Where does arc cosine live? 1 and 2. Cosine's x, so where's your x value positive at? 1. So what family member of pi over 4 is in quad 1? Very good. You have about 10 of these in your test. Math workshop test. So we need to be paying attention to this, remembering it. 14. Arc tan. Where does tan live? 1 and 4. This tangent's negative. So what quadrant are we looking at? 4. Which reference angle gives you our arc tan value square root of 3? Pi over 3 or pi over 6? Pi over 6. No, we don't. Which one? Pi over 3. Pi over 3. Pi over 3. Pi over 3. Now, I know that 5 pi over 3 lives in quad 4, but can I put that value? So what's another way I could write 5 pi over 3? Negative pi over 3. Alright, solve each problem. Probability. We have all these choices here. How do I find out how many different combinations do I have? 4 times 3 is? Times 2 is? Times 2 is? Very good. So 4 times 3 times 2 times 2 is 48. Now, Lance's math quiz has 8 true-false questions. How many different choices for given answers to the 8 questions possible? Okay, you have how many questions? Each question has how many choices? 2. What's 8 times 2? 16 is your answer. Each question on a 5-question multiple choice, how many questions do I have? Has answer choices A, B, C, D. How many answer choices is that? What's 5 times 4? 20. Very good. Are there any questions on that? Now, what we're going to do, we're not quite done yet. I know. I just want us to identify as a P or C down here. Arranging 5 different books. Would that be permutation or combination? Because you're placing. Selecting 3 of 15 flavors of ice cream. What is that? Choosing 2 different pizza toppings. Okay, and tomorrow we can finish this. Okay, put that away. And now let's turn to good old page 15. We start in our second to our last unit. We just finished up limits. I left the test here last night. Didn't have a chance to grade them. Figured out by the time I get to the red light. And I'm going to turn around and get those. And I just worked it. That was a too easy test. I'm going to make that one a little bit more harder next year. A little bit harder next year. Because I don't y'all think that test was too easy. That limit test would need to be. That was great. I think we worked some of those problems in class when I started looking at some of those. A little bit harder next year. Alright. Now, let's talk about slope for a minute. If you have a straight line, you know how to find the slope of a straight line. Using a formula and by using a point. A linear function. You could choose any 2 points on that straight line that could give you the slope of it. But remember when we started talking about quadratic functions and cubic function, can you find the slope of those type? Can you find the slope of those? No. You have to use what's called average rate of change. You have to pick 2 points on there and just find the slope at between those 2 points. Because it might be different at other parts on that graph, couldn't it? Like on this parabola right here, I could choose a point here and find the slope of just that region. But you remember, that's when we used average rate of change at the beginning of the year. Y'all remember that? and it was equal to the slope between 2 points. So the first blank is slope. It is average rate of change is the slope between 2 points. And remember that slope is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. The line through 2 points on a curve is called okay, if it touches the graph in 2 spots, is it a secant line or a tangent line? Which one, secant or tangent? Secant. If it touches it twice, it's a secant line. If it touches once, it's a tangent line. Alright, remember the formula for AROC. This was our first test of the year, AROC. X sub 2 minus x sub 1 was on bottom, just like the original slope. But remember, it was your y value of that and the y value of the first one. Sorry, it's right here. It's pretty right there. Remember, that was the AROC. Remember, slope has y sub 2 minus y sub 1. Doesn't f of x mean y value? Y'all remember, doesn't that mean y value? So that and that is technically the same formula, isn't it? Okay. So on this particular graph right here, it says for the given function, f of x equals x squared plus 2, determine the AROC between these points. Here's my function, and I want to know what the AROC. We're just reviewing AROC right here. We're finding the average rate of change between 1 and 3. What is going on between 1 and 3? We're finding the slope of this secant line right here. We're finding the slope of the secant line right there. Alright, so let's find this here. Let's set this up. AROC. That would be f of what? 3 minus f of 1 over 3 minus 1. Do you understand how to set that problem up? F of 3 minus f of 1 over 3 minus 1. Now you can plug this in your head. What's 3 squared?
9.
9 plus 2 is? 11. Now plug in 1. 1 squared is? Plus 2 is? 11 minus 3 is? 8. Come on, talk to me. What's 3 minus 1? 8 over 2 is? So the slope of the secant line right here is 4. Now let's find the AROC of 1 and 2. I want to know what's going on between 1 and 2. So AROC equals f of 2 minus f of 1 over 2 minus 1. Plug 2 into the formula. 2 squared is? 4 plus 2 is? Minus, plug 1 in, that's 3 over 2 minus 1. So that's be 3 over 1 equals 3. The AROC is 3. I want you now to do, I'm going to give you about 10 minutes to do, or about 8 minutes to do C, D, E, and F right now. C, D, E, and F. You first do it by yourself, and then you can compare your answers in your group. I'm going to run to the restroom just a second. noticing the values as you go down the page? Come on now, this shouldn't give you any trouble, and I got some, but we ain't finished it yet now. You're plugging f of 1.25 minus f of 1 over 1.25 minus 1. What are you noticing is going with the values? Getting closer and closer to what? 2. What do you think that value is? We just studied it. We're getting closer and closer to what value? It's a limit, isn't it? You notice we're getting closer to, we started from 1 to 3. Then we went from 1 to what? 2. 1 to what? 1.25. So we want to know what's happening as we get closer and closer and closer to 1. What is happening? It's getting, the values get closer to what? 2. When you're, okay, that's, look at me. This is a very important big idea you need to hear right now. A rock is when you're between 2 points. Now we're going to I rock. What is happening at that very instance? Instantaneous rate of change. I want to know what is happening at x equals 1. That very second, x equals 1. That is that value 2. You see what it's saying? We started off wanting to know the slope between 1 and 3. What's going on in that interval? That's average rate of change. Now I'm getting closer. I'm finding the limit as I get to that very single x value of 1. That's instantaneous rate of change. You see the difference? That's IROC. And that is what we're going to be looking at. You should know what average rate of change is by now. Now we're going to focus on IROC. What's happening at that very instance, that instantaneous moment in the graph. Does everybody understand so far? Okay. So, if A of x is the AROC, what would you guess the limit is x equals 1? You already told me it's approaching 2. Now, hold on. Some people was, in my dual enrollment when we did this, was confused. They said, Mr. Chester, if I look at x equals 1, that's approaching the value of 3. Why is that 2? That's not saying the limit. That's not saying what the limits. This is what the, okay, that 2, that, okay, y'all are not paying attention. Some of you are in La La Land. I really need you to pay attention or you're going to be lost. What is that 2? That 2 is the slope of the tangent line at x equals 1, okay? That's not what you see in the graph. You say, Ms. Chester, it's looking like it's at 3. No, this value right here has nothing to do with what you see in that graph right there. When you want to know what's happening at a very instance, that's a tangent line because how many, you're worried about x equals 1, so that means there's 1 point on the graph, okay? Secant line in the beginning, the secant line that we had, that was 2 points. So if I'm only worried about what's going on at 1, that's a tangent line. And that is the slope of that line at that. That's what that significance of that is. You got me? Okay. So this is your instantaneous rate of change. What the rate of change is exactly at 1. As your secant lines go through points closer and closer to 1, they tend to look like the same line. This line that you're getting closer to a product is the tangent line. What we're getting at that very instance. All right. Now, skip page 16. I want to go to page 17. And we're going to take a moment to look at these big ideas. Everything up here is very important, and you've got to know this, okay? The slope of a secant line, that means it touches the graph 2 points, is your average rate of change. That's what's going on between this x value and this x value. But the slope of a tangent at a point, that means 1 point on the ground, at that one instance, is your instantaneous rate of change. I will refer to this as AROC and IROC, okay? Does everybody see the difference between those two? This is between 2 points. This is at a very one point right here. That's a tangent line because it touches one spot. The graph that represents the slope of the tangent line is called the derivative. The derivative. This is the graph that represents the slope of it. The equation for that line is called the derivative. I call the derivative aka slope generator. So when you find the derivative of this function, you say, okay, so Mr. I got this derivative. What does this tell me? Let's say I had this function, I found the derivative. I got my derivative over here. I want to know what's going on x equals 2 in the graph. I plug 2 into this equation. That gives me the slope of the tangent line at that very moment, the IROC. That gives me my IROC at that moment. The slope is the formula, not slope, the derivative is the formula that gives you your instantaneous rate of change at that very moment. Does that make sense? So that's the derivative. Now, the derivative of f of x, now this is very important, is written as, this is the notation of a derivative, f apostrophe. You read that as f prime. F apostrophe x, or f prime, is pronounced f prime of x. I call it f prime, okay? Use the correct vocabulary, or f prime. If you use that notation, if you see f of x. If you see y equals, use this notation, y prime, or you can use dy over dx. You can either see the apostrophe or you can see dy over dx. Those both mean derivatives, okay? That's the notation for derivatives. Alright, so the derivative of the function, I call that aka slope generator. Okay? You need to be writing notes on your paper, okay? This is the formal definition for the derivative. And we're going to be working on this the rest of the week. The formal. It's the long way of doing it. Next week, once you appreciate this, I'm going to show you the shortcuts to derivatives. But this is the long definition. F of x plus h minus f of x over h as the limit as h approaches 0. Now, the derivative measures the steepness of a graph at a particular point. The slope of the tangent line. The derivative measures the steepness of a graph at a particular point. Now, I'm going to come back to this key parts up here in just a minute. I'm going to come back to this, but I want us to show you how to find the derivative. So let's look at number 5 here. Okay, I'm going to write this on the sheet back. Now, if you don't pay attention, you'll be lost and lost for the week now. So make sure you pay attention. So let's look at number 5 here. I have this function, x squared plus 3x. So right here, I have this function. This is my original function. I want to find the derivative. After I find the derivative, I want to know what the IROC is at x equals negative 2 and x equals negative 3/2. I want to find the IROC at those 2 points, but first I have to find my derivative, because I have to know my derivative first, because isn't it my slope generator? Once I find my derivative, that's when I plug these in to find my IROC. Does that make sense? Is everybody good so far? I'm going real slow this day because I don't want you to get confused. So let's find the derivative of this function. Okay? Now, this is the formula I'm using. I'm going to write this over here just so you can see. Okay, there's my formula. Let's see how you think we need to attack this formula. It says f of x plus h minus f of x. If that's in parentheses, what do you think we need to do with it? What do you think? F of x plus h. Come on now. This is my original, and I want to find f of x plus h. Please, someone say it. You just got to do what with it? Plug it in. Plug it in, plug it in. I'm going to come down here and find what f of x plus h is. That's my original function. I'm going to plug that in for my variable. This is not hard, but it's a long process, so you need perseverance. I'm going to end up foiling that, aren't I? By this point in your math career, you should be able to foil that in your head. But if you can't, you need to come over here. I'm going to foil it in my head. X plus h squared is x squared plus 2hx plus h squared. If I came to sign forward it, that's what I'm getting. You should be able to do this now. Plus, I'm going to distribute that, 3x plus 3h. Now, f of x is just take x, plug it in. Will it change the formula there? No. So now I have my two parts to put in this formula, so I'm ready for this formula now. F prime of x equals the limit as h approaches 0. If you can't see it, tell me to scoot it up, okay? Now this first part, so I'm going to put this part here first. I'm going to put it in parentheses. Minus the f of x part, which is up here, all over h. You have about 7 of these on your test in a couple of weeks, so it's very important we learn this. What does that minus do to everything in that parentheses? Change to it, okay? So f of prime of x equals the limit as h approaches 0. I'm going to rewrite that without parentheses. Changes that. Now, at this point in the game, notice your x squares cancel out, your negative 3x and 3x cancel out. Everything that didn't have an h with it canceled out. Did you notice that? Everything that didn't have an h canceled out. That's what should happen at that stage. If it didn't, you did something wrong, you need to go back and check. Everything without an h. So now I got f prime as the limit h approaches 0 of 2hx plus h squared plus 3h over h. Now I'm ready to take the limit of that. Well, we just had a test on. I'm going to try direct substitution. I plug 0 in. What do I have in the denominator? 0. So I got to use one of my toolkit strategies. I need that h to leave the denominator. What strategy do you think I can use there on the numerator? Well, I need a factor first, don't I? And then cancel out factor. So I'm going to take an h out on top. That leaves 2x plus h plus 3 all over h. These h's cancel out. Now I can apply direct substitution. If I plug 0, now this is where, let's talk about this. Which variable am I plugging 0 in? Which variable is approaching 0? H. You plug it in not for x. I plug 0 in for h. What am I left with? 2x plus what? 3. That's your derivative. That's your derivative. So, f prime of x equals, I plug 0 in, I get 2x plus 3. That is my derivative. That is my derivative. Calculus is based on limits and derivatives. First chapter is limits, second chapter is derivatives. And then you use it throughout the whole 3 calculuses. Now, that is your derivative. Now, I want to know what is going on which point. X equals negative 2. I want to know what my IROC is going on at negative 2. Where here is the equation for my tangent line. Okay? So if I want to know what's going on at negative 2, I'm going to plug it in. Watch this. F prime of negative 2 equals 2 times negative 2 plus 3. So there's my derivative. I will know what my IROC is at x equals negative 2. What's 2 times negative 2? Plus 3 is. So the slope of the tangent line at that instance at x equals negative 2 is negative 1. Well, that's part of your answer because you want the derivative and then you wanted that answer. That's your derivative and that's your IROC at that particular point. Now, what was the other point we want to know? X equals what? Negative 3 halves? Okay, now I'm going to come over here. F prime of negative 3 halves equals 2 times negative 3 halves plus 3. 2 times negative 3 halves is negative 3 plus 3 is 0. So that is the slope of the tangent line at that moment in time. Now let's talk about what is going on with this right here. Let's talk about what's going on here. What does this tell you about the graph if you get a negative answer here? If you get a negative answer, that means the graph is decreasing at that moment in time because it's negative. If you get a positive, it means the graph is increasing at the time. What do you think is going on if I get an answer of 0? What? Not constant. It's turning like a local max and min. You know how they have the hills and valleys? If you have 0, that means that's at a local max or min. Does that make sense? Let's graph just to show you. What's my equation? X squared plus 3x. Alright, so I have, what was my 2? Negative 2. At negative 2, it's still decreasing before it gets to that valley. You see that? And then negative 3/2, isn't it at that valley? That's why my derivatives are the signs they are. Does that make sense? Yes.
What's that program?
It's TI Smart View. It's made for smart panels. Yeah. You can't buy that off an app or anything. Alright, let's look at another one. Number 6. What is my original function? Ooh, this is a good one here. F of x equals 3x squared plus 12x minus 1. And I want to find the derivative. Okay? And knowing that this is my formula, guys, look up here under the blue. The limit as h approaches 0. Before you even plug anything in this formula, you need to know f of what? X plus h, and then f of what? Come on, talk to me. Before you do this problem, before you plug anything in this problem, aren't you going to need to know that? Aren't you going to need to know that? So don't you need to do that first before you even plug anything in this formula? That's what I'm getting at. Does everybody understand that? So I'm going to find f of x plus h first, okay? I'm going to find that part first. So I'm going to come under here and find x plus h. So that's 3 times x plus h squared plus 12 times x plus h minus 1. X plus h squared is x squared plus 2hx. You said, Mr. Judge, I have xh. That's fine. Plus h squared. Distribute, that's going to be 3x squared plus 6hx plus 3h squared plus 12x plus 12h minus 1. All that's got to go with the first in my formula. F of x is my original, so I don't have to do anything on that. But now I'm ready for my formula. The limit f prime of x equals the limit as h approaches 0 of 3x squared plus 6hx plus 3h squared plus 12x plus 12h minus 1 minus, I'm not going to be able to fit all this in, 3x squared plus 12x minus 1 all over h. I'm not giving you this formula on the test, so you have to know that by heart, that formal definition. So today our learning target was I can find the derivative by using the formal definition. That's the formal definition right there. Does everybody understand? That is the formal, original definition of a derivative. And that's what we're practicing all week. Wednesday, Thursday, Fridays, how to use this formal definition to find the derivative. Okay? We understand our goal here? We're not covering anything else new. We're going to do this for 3 days. Okay? And maybe even Monday. Alright. Now, I'm going to rewrite it without the parentheses. And the reason I put the parentheses again is to remind you that this minus changes everything, okay? So I got 3x squared plus 6hx plus 3h squared plus 12x plus 12h minus 1. What does this minus do to everything? Changes the sign. Now when I start to simplify, at this moment in the game, everything that doesn't have a what should cancel? H. So I look, does 3x squared cancel? Yes. 12x cancels. The negative 1 and 1 cancel. Yes, I did it correctly so far. So f prime equals the limit as h goes to 0 of 6hx plus 3h squared plus 12h over h. Okay, that looks a whole lot better. At this point, I've simplified. I'm going to try direct substitution. I'm trying to find this limit. Well, if I take 0 and plug in, and I still get what in the denominator, guys? 0. So I'm not quite done yet. I have to use one of my toolkit strategies. I want to get rid of that h on bottom, so I could do what in the top? Factor out of h. And then cancel it. So f prime of x equals the limit as h goes to 0, take out of h, cancels out. I'm going to plug 0 in because I'm worried about what h is approaching 0. So I plug 0 in here. What's left in this? 6x plus what? If I plug a 0 in for this is gone, isn't it? So my derivative is 6x plus 12. Do y'all see that? That is my, once your h's are gone, you're done with the problem, okay? So that is my derivative. That is my aka slope generator. If I want to know the slope of the tangent line at any instant, the IROP, I take the x value and plug into that formula right there, the derivative. Does that make sense? Okay. So I want to know on that question what is going on at x equals negative 2. So what is my IROP, my instantaneous rate of change at x equals negative 2? So I do f prime of negative 2. I plug that into my derivative. Negative 12 plus 12 is what? So what is going on in the graph at that moment? It's either doing what? It's turning. It's a max or a min. It's turning at that moment. The other one is x equals what? 1. So f prime of 1, 6 times 1 plus 12. 6 plus 12 is what? That's a positive value. So what's going on in the graph at that moment? It's doing what? It's increasing. Does that make sense? This is your derivative. This is your IROP, your instantaneous rate of change at that moment in time in the graph. Does the connection make sense? Yes. If I ask you, okay, this is the derivative, you would label that the derivative. And then you would label these as your IROPs. Okay? Now, I only gave you one homework problem now. I want you to try because this is new. It's on the back of this page. Turn it over. It's number 7. I don't know why I put number 3. It's number 7. Now, in this one, guys, when you set up, this one's probably shorter than the other two we just did. But you're going to have 1 over. Now, let's see here. If I plug in x plus h, I'm going to have 1 over x plus h, minus 1 over what? X. All over h1. I want to find the limit. I'm going to find a common what? What will be the common denominator between x plus h and x? Both of them on it. So that's what you're going to use. You're going to use your toolkit strategy, but you got to find. That's why we learned the unit before we did, because you have to use these strategies. Okay. So I just want you to try that. Tomorrow we're going to go over 7. If you want to try it 2, you can. But we're going to do these 2 examples, and then we're going to practice this. Okay. But at least try 7. Does everybody understand? But when I say formal definition, you understand that that's what I'm talking about. Do y'all? I need a hand signal. Hand signal, everybody. If you understand when I say formal definition, I mean that method there. Okay, now I need a hand signal about how you feel on this. Be truthful. We're going to spend 2 to 3 days on this. So, okay.